Okay, thank you everyone for joining in. Welcome you to this live machine learning class on YouTube. I'm thrilled to have all of you here with me today as we will be exploring the fascinating world of machine learning. Before we get started, I just want to wait a little bit time so that we have enough audience. People are still joining in. Thank you all again for joining in. Hello, Ravi. Hello, Pratibha. Before getting started, a short introduction about myself. My name is Satyajit Pattnaik. Welcome you back to my channel. We are doing live sessions almost after 2 years. So, most of you might not know this because most of my previous students that were part of my previous live classes, they might have already become data scientists or analysts, so they might not be joining these classes. So it's completely new for you that I usually do live classes. Yes, I used to do long back, 2 years 3 years back, but now I'm again back. Now the agenda of this particular series is going to be machine learning. How many classes are going to be conducted for machine learning? We are going to have 3 weekends, Saturday Sunday, next Saturday Sunday, and next Saturday Sunday. We will be talking about machine learning in depth: classification, regression, time series analysis, clustering, each and everything. So the first question that will come to your mind is 12 hours enough? Well, 12 hours is good enough. Of course, machine learning is that kind of field which might even take 100 hours to learn, right? If you ask me to teach machine learning, I can even take 100 hours classes, but the more in depth you teach, it becomes boring for people. So that's why I'm restricting it to 12 hours. And then obviously we'll have projects in this, we'll have many other things. Okay, so it's going to be a fascinating learning for you. So do tune in on Saturdays and Sundays, today, tomorrow, and next weekend and next weekend. I hope my voice is audible properly. Can I get a confirmation in the chat room? Um, and then we'll quickly get started. So just write yes if you are able to hear me. There is a delay, of course, because yeah, there is usually a delay of 30 seconds. So I'll wait for your comments. Yes. Okay. One last thing before we get started. Can I quickly get to know about you? Let's not take more time. Just quickly talk about yourself in the chat box, whether you are an experienced professional or you are a student. If you are an experienced professional, just write down 5 years cloud computing experienced professional, or 5 years into MBA into HR experienced professional. If you're a student, just write down student 2024 graduate. Just quickly do that, and then we'll get started with the program. I'm waiting. I'm looking at the chat box right now. Student, okay. 2 years into data analytics, perfect. So 11 years MBA finance professional. That's really good. MBA professionals, financial professionals. It's a very good thing to learn AI, generative AI. Of course, we are going to do generative AI in the upcoming classes, but yeah, this series is completely dedicated to machine learning, right? Want to be in data analysis. Okay, and what about others? 42 people. I was not expecting that number of people on the call. I will like to retain them till the end of the session. If I am able to retain them, then I'm successful. Okay, so most of you are freshers, experienced but not in data science. Great. Now, little bit of pitch about my program. I'll not take much time. This is just for people who don't want to wait for YouTube live classes. They want to study machine learning, deep learning, everything in a very structured manner. For them, that is the program. Okay. As I told you, I usually don't pitch a lot about my ongoing courses. Um, People who do not want to spend, I'm just repeating, I'm not forcing you to spend a penny. If you don't want to spend, you can just tune into my channel, learn machine learning, and in the upcoming classes we will be teaching NLP, generative AI. See, the only problem in YouTube learning is it will be prolonged, right? By the time I teach generative AI, maybe it will be 2 or 3 months down the line, right? So for people who want a structured program, for them I already have a data science and AI program. I'll quickly share something about this, which will basically tell you your career path of becoming a AI engineer. Okay, so it usually starts with, I'll quickly scroll through. Okay, it usually starts with Python. Python is the basic core concept behind anything when it comes to data analytics or data science. Python is the go-to algorithm, go-to programming language. Earlier days we used to also study R and various other things, but nowadays, with generative AI popping up, a lot of things have changed in the recent one last year or last 1 year or 2 years. Python is the game changer. And of course, down the line you also need PySpark, but again, PySpark is not mandatory. So Python, statistics, SQL, these are the three different concepts that you definitely need to know. Repeating once again, all of these contents are already provided on my channel free of cost. If you go to my playlists, there is a playlist on Python, there is a playlist on statistics, there is a playlist on SQL. So do not worry about it. Like sir is attempting to sell courses. Of course, I am attempting to sell courses, but I'm not forcing you. After SQL comes machine learning. Now, if you want to become a AI engineer or a generative AI engineer, it starts from machine learning. And that is what we are going to study in the next 3 weekends. Okay. Machine learning, then comes natural language processing, then comes deep learning, then comes transformers and generative AI. So one of my program is already there. In case you are willing to, the cost will be around 7,999. This is noted as 9,999, but I am selling it at 7,999. It's a well structured program. In case you want, you can definitely reach out to me and I'll probably talk more about that. Okay, coming back to the agenda. um, Machine learning. Now, before getting into the agenda, some of you might already know little bit about machine learning, some of you might not, right? So we will quickly get started with a simple understanding on different career paths. So probably I'll take hardly 10 minutes to explain this thing. Okay, so when it comes to the data domain, okay, I'm assuming everybody who has joined this call, either you want to become a data analyst or a data scientist, right? So, in the field of data, majorly there are three career paths. Okay, and this I'm talking with respect to, I would say 2023. Okay, then I will talk about the changes that has come recently in 2024. In 2024, we have a wave of generative AI, right? So by 2023, these were the major three career paths. One of them is data analytics, one of them is data science, okay, and one of them is data engineering. Okay, all of them are related to data. Now, data analytics is something where you analyze the data. Okay, so you are responsible for analyzing, basically collecting data, analyzing, and visualization. These are the things that you need to become a data analyst. What are the career tech stacks that is needed? Python is needed, not in depth, but at least to certain extent. Okay, so I would write it down as Python plus ED, exploration of data. Again, Python, ED, everything is available on my channel, and I'm not compromising on contents. You can go ahead and check. For Python, I have 8 hours of video. For ED, I have 6 hours of video, and trust me, that is more than enough for you to get started. So so you don't have an excuse to get started with the field of data. Many people come to me, sir, I don't want to spend anything, can you guide me? Yes, definitely there are. YouTube has a bunch of videos. You just need to find the right videos, that's it. Now, if you don't want to do that, you need spoon feeding, then only comes the paid courses, where everything is given to you like a plate. Everything is served to you. You have rice, you have curries, you have salad, you have everything. You just have to eat step by step, and then you become a data analyst or a data scientist. Go for job applications, apply for jobs, and get it right. And of course, in paid courses, the only advantage is guidance, which is not there on free courses, right? But there is no stopping. If you don't want to spend, it's completely fine. So Python plus EDA is needed for data analytics. Then comes SQL. SQL is top priority. I will write it down as star. The reason being it is top priority. If you go to companies like Amazon, Google, or even big companies like Morgan Stanley or JP Morgan, they will grind you in SQL. Okay, that means you need to be good at Windows functions, stored procedures, complex join queries. So very very complex SQL is needed. Basic से कुछ नहीं होगा. Okay. After that comes basics of statistics. Again, this is dicey. If you go back to Edureka, Simplilearn, or any other online platforms where they are selling data analytics courses for 60K, 80K, they will not have statistics in their program. But statistics is needed because if you don't understand the basics of probability or skewness or kurtosis, you are not able to do anything. Analysis is all about statistical knowledge. So statistics is needed. Then comes a visualization library. Visualization libraries means various Python libraries are there, like Plotly, Seaborn, Matplotlib. So I will consider that as part of Python. Okay. So here I will write it down as BI tools. BI tools, either or, Power BI or Tableau or QuickSight. Okay, either or is good enough. See, there are multiple other tools also. Looker is there, Click is there, Alteryx is there. Okay, many tools are there. Data Studio is there, but Data Studio is nothing but uh, Looker is basically the replacement of Data Studio. So you know, most likely um, these are the top two. Okay, these are not important because Power BI and Tableau themselves take almost 90% of the market. We will start with ML very quickly. Don't worry. There are people who don't have a minute understanding on the prerequisites. That's why we are taking like 5-10 minutes. If you don't need this gyan, go for a water break, come back in 5 minutes. We will start with ML. Okay. And then after BI tools comes predictive analytics. Predictive analytics is basically your bridge towards the data science. And in data science, you would need machine learning, NLP, deep learning, and various other things. Apart from that, you also need this. Data engineering is mostly the ones who basically work on pipelines, automations, data transformation projects, ETL tools. So, data engineering do not have a good knowledge on data science or machine learning algorithms. Now, 2024, when the wave started, I would say around 2023 end. Now companies are going crazy for generative AI. I will be very honest with you. From the past 1 year, I have not worked on any classification problems. I have not worked on any regression problems or any time series problems. I have been working into generative AI. And if you believe me or not, I have done more than 100 proof of concepts. So which means I have more than 100 project ideas when it comes to banking, research domain, insurance, any kind of industry. If you tell me, I will be giving you an idea about generative AI. Okay, so nowadays we have generative AI, and to learn generative AI you need to know transformers and NLP. These are mandatorily needed. Okay, so today we are here, we are going to talk about machine learning, assuming that you all know about Python, assuming that you know little bit basics of statistics. If you are good enough on those topics, you will be able to understand machine learning. Okay, so let's get started with the agenda. I'll go through the comment section probably during the break. For now, let me go ahead and start the class. We will take the questions probably at the break. Okay, maybe at 9 o'clock, 9 AST. Okay, we will discuss, and at the end of the session, at 10 o'clock, we will take some random questions which is not related to what I was teaching. Okay, so let's jump into machine learning. So the agenda is very simple. Over the next 6 classes, we are going to focus on the different types of learning. We will be talking about feature scaling, regression algorithms, classification algorithms, clustering algorithms, association rule learning, ensemble techniques, time series, dimensionality, and hyperparameter, and of course, projects. Sorry, I was writing down use cases. So we will be working on projects also. Okay. And my projects are always end to end. I just don't fool people with just building something and showcasing, right? So we will be building an end-to-end project. An end-to-end project means uh, we will be building it on Flask and see whether we are able to deploy it on AWS. This is my end goal. So 11 hours I'm going to teach you all these things. 1 hour I'm going to work on a project, and let's say we will add additional 30 minutes in the final class to probably deploy it on AWS instance. Okay, so you have an end-to-end pipeline on how machine learning works and how you convert your projects into Flask applications, and then take the Flask applications and deploy into AWS. I'll quickly show you one of the applications that I have created for my current company. Now this is hosted on AWS. Now this is a generative AI project. If you go and ask something, it will answer. See, the idea here is we will be doing something like this. Our project will have a beautiful UI, and then after that, we will be able to interact with the application, and the application will be hosted on AWS. Okay, that is our end goal. So we will be working on the classification or regression problem. Okay, now all good so far. Introduction. Let's get started with basics. I see people are dropping. There were 52, now it's 47, which is fine. Unless and until 50% of you drop, I'll still continue. Okay, talking about basic things, AI. Many people ask me this. So, what is the difference between AI and data science? Many recruiters, many tech recruiters also have this problem. They don't know what is AI and what is data science. Data science is the field of study. Whenever you deal with data, whenever you are working on data, you are analyzing data, you are visualizing data, you are kind of working with data, that is called as data science. That the field is called as data science. Okay, now AI is artificial intelligence, an intelligence that is achieved artificially. What is natural intelligence? What you have in your brains, right? Hereditary. You're getting something from your parents. Natural intelligence. um Ah, thank you. Thanks a lot. Yeah, I'll be very honest with you. I'm very keen on numbers, because if I'm teaching to 5 people on YouTube, I'll better not teach. So if, because I'm giving everything for free right now, so if I don't have a proper audience, probably I'll stop teaching. As simple as that. I'm dedicating my weekends, especially weekend nights, which I usually go for parties and all. I'm dedicating that to teach you all for free. So better the numbers be good. So AI is nothing but artificial intelligence that is artificially achieved. Okay. Now there are different areas of research that basically leads to AI. And one of these areas of research is machine learning. Okay. Another area of research is NLP. Another area of research is robotics. Another areas of research is autonomous vehicles. So all of these are leading to AI. Uh, it's going to be a 2 hours class. So 3 weekend is what I am planning to complete ML. So if today will be 2 hours, tomorrow will be 2 hours. If I see we are not on track, next classes will be 3 hours. But I will inform in the WhatsApp groups. So please join the WhatsApp groups. The link will be in the description. So please join them, because all the major announcements are done on that particular WhatsApp group. Okay. So different areas of research leads to AI. Now I'll just zoom in ML. So let's say this is your AI. Here comes ML. Now DL is basically another subset of ML. Okay, people think DL and ML is different. No, DL and ML are connected. DL is nothing but the subset of ML. Now, if I zoom in, here comes generative AI. So, generative AI is further subset of DL. So, generative AI is nothing but it's a part of machine learning. So, many people don't know that. Even recently, I'm applying for jobs. The tech recruiters don't know what is the difference between AI and data science. What is the difference between AI and ML? I send them resumes in bits and pieces. I write generative AI and Llama 3 and all those things. They come back and they're like, oh boss, you don't have good experience on AI. And then I have to explain them, boss, ML is AI. And then and then they take my resumes. So there is a gap in the industry. Many people don't know these jargons. So AI is just fancier name, that's it. Underline, we are going to study about machine learning, which is nothing but an area of research that leads to AI. Now, this is a very simple areas of researches that I was talking about, right? Different areas of research leads to AI. Machine learning, deep learning is a subset of ML. We have NLP, translation, speech to text, text to speech, robotics, autonomous vehicles. All of them leads to AI. Okay, understood. Now, if anybody asks you, you will be able to answer. Data science is the study of data. AI is artificial intelligence that can be achieved through different areas of researches. ML is just one of them. I'll not study about, I'll not go through this slide in depth, but you can just have a look at it. Slides will be provided to you as part of the description, but after the class is over, not now. Okay. So do not worry about slides. I will pass you on. I don't have to talk about this thing. Why do we need machine learning? Everybody knows why do we need machine learning, right? Data is the new oil. Everything is revolving around generative AI right now, right? So machine learning is a very very key tech skills that is needed in anybody's profile. Okay, now comes the first technical topic, which is types of learning. So I'll switch between PPT to paintbrush because I usually love teaching on paintbrush. In fact, I will switch to Miro because I love this tool. I'll probably use this tool for explanations. Let me just create a new board. I will share this link with you, so do not worry about it. So we will be doing hands-on or whiteboarding here. So machine learning. Uh, Machine learning. Okay, what are the different types of machine learning? There are different types. One of them is supervised, one of them is unsupervised, and one of them is reinforcement. Okay, I'll just zoom in a bit. Okay, first try to understand these three types of machine learning. What is the difference between each of them? Supervised is that kind of learning where you are dealing with labeled data. Okay, see, if you have any doubts with respect to technical questions, feel free to write down the chat box because I'm looking at the chat box in parallel. Any questions that you are raising that is not related directly to what I'm teaching, I will take those questions during the break. I hope it is clear. Okay, so the first thing is supervised learning. Supervised learning is that kind of learning where you are dealing with labeled data. What do you mean by labeled data? Labeled data means, as a data scientist or as a machine learning engineer, you know what needs to be done. Now, for an example, you are working in a telecom company. You are working in a telecom company as a machine learning engineer or as a data scientist. Okay. Now, your manager has given you a particular use case that boss. Um, so I'm talking about Vodafone. Okay, I'm giving an example of Vodafone. Well, in India, Vodafone is not Vodafone. Vodafone is Vodafone Idea. I hope everybody knows it is vi.com. I think Vodafone Idea has a merger, right? Because they are not able to fight with the tech giants, with the telecom giants in India. Jio is the largest giant company right now. So, okay, forget about it. I'm taking an example of Vodafone. Your manager comes to you, you are a data scientist. He tells you, boss, our company has a churn rate of 25%. What is the meaning of churn rate? Churn rate means the number of people leaving the company and switching to any other company. Now, for example, tomorrow Airtel gives you an offer. Boss, I'm giving you everything for 99 rupees. In 99 rupees, you get 10 GB internet, unlimited calls. And in Vodafone, let's say some users are paying 399. Obviously, some people will switch, right? It's a normal human tendency. So your company manager has told you the churn rate is 25%. Can we get it down to 20%? Now the data that you have collected, it has multiple features. It has gender, it has geography, it has tenure, it has multiple features. It also has a column called as churn, which basically tells whether this customer is churned or not churned, churned or not churned, churned or not churned. Okay. What you need to do as a data scientist, now let's say you have 1,000 records. Okay. What you need to do is you need to take this and you need to train a machine learning model. The model will learn about the features, about the data. Now after your model is ready, you need to test the model, right? How the model is behaving. So usually what we do is we divide the data into two segments. One is called as training segment, one is called as testing segment. Training segment is gone into the machine learning model. So imagine your training segment is 700 records and your testing segment is 300 records. Okay. So 700 records are being trained to the machine learning model. So model understands something. After that, when you are passing, when you are testing the model, you only pass this information, you don't pass this information, you only pass these information. So you pass them and the model predicts. Okay. Now let's say, okay, so let's say the model is predicting the first customer, the model is predicting as no, second yes, third no, fourth yes, and goes on. So original records you already have. This customer originally is not churned, this is churned, this is not churned, this is not churned. Now considering these four records, what is the success rate? Your model is able to predict this properly, predict this properly, predict this properly, but this one it is giving you a wrong prediction. So the accuracy is 75%. But try to understand, in this case what are you predicting? You are predicting this column. This column in the field of machine learning is called as y variable or a predictor variable. You know that you need to predict this particular column, so it can also be considered as a labeled data because the data is labeled. You have labelings, you know what needs to be predicted. Another example of labeled data is Let's say you have this thing. I'll go to Google HKD2 INR. So I stay in Hong Kong. Let's say this is my HKD2 INR rates. Let's say I will take a snipping tool and I will come back to Miro, Miro board. Now this is my data. Okay. Now what is this data having? It is having two things. One is date and one is having the HKD to INR conversion. Right. Now if you go back to 5 years back, 2019 July, what is the value? 8.81. So July 2019, it is 8.81. August 2019, the value is, let's say, 9.1, and goes on. Now what is the value? July 2024, it is 10.72. July 2024, it is 10.72. Now if I ask you, boss, you have this use case, you need to do a forecasting of August, September, and few other months. So my first question is, what are you going to forecast? Which column? You are going to forecast this column, right? So in short, you know what you are going to do. So in this case, what will be my y variable? This column will be my y variable or my predictor. And then I'm going to predict this particular numbers. Let's say August it is 10.8, September it is 10.85, and dot dot dot. So this is how the forecasting is. You are able to get my point. Again, this is a supervised learning problem. Now I talked about y variables. What about these variables? Talking about gender, geography, blah blah blah. These are all called as x variables. In the field of machine learning, we call it as x variables. Okay. We also call it as independent variables. I will I'll probably take a new screen. Let's say I'm talking about one particular data set. I have gender, I have geography, I have tenure, I have age, I have salary, and I have a column called as whether the customer is churned or not churned. YN. Sorry, give me 1 second. People are nudging me on WhatsApp. Can anyone suggest? Okay, sorry. It's a different context. Okay, so these are my different columns. This is my data set: male, female, male, dot dot dot. Now, as you're going to predict this column, this becomes your y variable. We also call it as predictor. We also call it as dependent variable. Why do we call it as dependent variable? Because this is dependent on these columns. Based on these columns, the customer is churning or not churning. So what about these columns? What do we call? We call it as x variables, also called as features, also called as independent variables. Okay, so that's the simple definition. That is supervised learning for you. Now, when it comes to supervised learning, there are majorly two parts. One is classification, and one is regression. Now, this is a classification problem, and this is a regression problem. Regression is something where you are doing a prediction on a continuous variable, continuous numerical variable. So the final output is numbers. Here, your final output is whether the customer is churned or not churned. Okay. Now, before we move ahead with unsupervised learning, talking about supervised. As I told you, there are two types. One is classification and one is regression. Only if you learn these two, you will still be able to do a lot of portfolio projects. What do you mean by portfolio projects? Portfolio projects means that kind of projects that you can work after learning few concepts and write down in your resumes. Practice it and write down. What are some of the use cases of classification? As I gave you an example of telecom, churn prediction. Churn prediction is a use case. Another use case is bank, credit card, frauds, disease detection. During the COVID, many people started analyzing X-ray images of uh, people suffering from COVID and not suffering from COVID, and then they started working on that. That is also a classification problem. So there are multiple use cases here. What are the use cases of regression? Let's say you are doing a temperature forecasting, or you are doing a house price prediction. You are predicting the price of a house given certain features. So there are multiple examples. If you need any help on identifying a particular use case around a particular domain, let me know in the comments, or let me know in the chat box. I will give you some examples. But this is your supervised. What about unsupervised learning? Unsupervised learning is that kind of learning where, as a data scientist, as a machine learning engineer, we really don't know what needs to be done. Now, for example, your manager gave you a bunch of records of customers, let's say 1,000 customers, and your manager told you, hey, can you do a segmentation of these customers? Segmentation means try to create clusters or try to create groups of those customers so that I can know which customers are similar to each other. Now, the first question here is, how many segments? How many segments do we create? Do we create 4, 5, or 10? We don't know, right? So here you don't have a y variable. There is no predictor variable. You just have multiple features. You need to use some unsupervised learning techniques to create some segments or clusters. So one of the classic problems that we solve here is a clustering algorithm. We will be talking about that. Recommendations, recommendation engine. Recommendation engine is also unsupervised. How many of you have created Netflix account recently or maybe in the past? When you create a Netflix account, I don't know if you remember this or not, but when you create a Netflix account for the very first time, Netflix usually asks three movies that you like. Okay? Let's say you give three movies, let's say Spider-Man, Madam Web, and then Iron Man. So all of these are categorized under sci-fi. So automatically your Netflix feed will be populated with all the sci-fi movies, right? X-Men, blah 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 blah. Okay, I don't know a lot of sci-fi movies, but it will be automatically updated. Why? Because of the recommendation engine. And recommendation engine is nothing but a unsupervised learning problem. In the future, if you go and watch a horror movie, let's say you watch Shutter, or you watch few other horror movies, automatically your feed will have some horror movies and majorly sci-fi movies, and that's how the recommendation engine changes. That's a great use case of unsupervised learning, right? Now, after unsupervised learning comes reinforcement learning. Now, reinforcement learning, the use cases of reinforcement learning is mostly into gaming industries. Okay, let's say you are playing a game of chess. You defeated the AI bot in 17 steps. You play again using the same steps, you will not be able to defeat, because the bot automatically updates its models. Some reinforcement techniques are also used in deep learning. So, if we have a deep learning class in the future, as I told you, if there are enough listeners, people interested in these live classes, then we'll go for the deep learning classes also. So, if we go for deep learning, I will cover reinforcement there also. Okay, so that's majorly all about your types of machine learning. Use cases, I have explained a lot of use cases. Amazon.com has recommendation systems, Netflix, Google Translate, all these are machine learning, NLP, somehow connected. Healthcare use cases, better imaging and diagnostic techniques, disease detection, providing personalized treatment. So there are multiple use cases when it comes to machine learning, NLP, and deep learning. Okay, so this thing I have already covered, so I'm not going through it in depth. So what happens is, you have your data, you divide the data into training and test, and then you train your model. I'll talk about that, um, probably in the whiteboarding. I'll try to explain you in depth how usually a classification problem is solved, so that you have a better understanding. So I'll talk about the architecture. Okay, how do we proceed with the classification problem? Example is understood, right? Let me take another example. Let's say, I'll take another example of classification. Let's say breast cancer prediction. Okay, so you have data. I'll not make it too big. You have data. This is your data. So you have different information, and you have another column. Let's say the column name is D, which tells you whether you have a cancer or not, cancer or not, something like that. So what are these features? Let's say I'll directly show you a breast cancer. Let's say I'll search for a breast cancer data set, breast cancer classification, GitHub. This is a very classic example. Okay, let's say if I have the data set, people are not uploading the data sets. Breast cancer classification. Okay, breast cancer risk prediction. They have Python notebooks. They don't have. Oh, they have data. Look at this data. Now imagine this is your data. Okay, so we have IDs. IDs means patient ID, right? Some people have, in the past, there are thousands and thousands of patients that have come to the hospital, right? Imagine there are 1,000 patients. Diagnosis, M basically means malignant, B means benign. Okay, so imagine it as cancerous and non-cancerous. So diagnosis is your final Y variable. So this is your column that you are going to predict. Okay, I'll go slow here because this is very important. These are all your information of the patients. Okay, radius mean, texture mean, perimeter mean. Now, literally, I don't know what the hell is this, but at least I know that these are all medical terms, right? So I'll try to give you a story. For example, 1,000 patients have already come to the hospital. Some of them are diagnosed with breast cancer, some of them are not. How somebody is diagnosed with something? You go to the hospital, you do some blood tests, right? You do some blood tests, you do some multiple tests, and then your test report comes, and then the doctor says you whether you are diagnosed with something or not, right? That's how the whole process works. So imagine these all are results from various tests, blood tests and all those things. Okay, so these are all your features. These are all your features. So radius mean, perimeter mean, blood sugar level, all these are different features. Ultimately what will happen tomorrow? Let's say a new customer, so not customer, new patient comes in, they go through the same blood tests and all those things. Now imagine they don't know this, right? They do all these tests. Our model will be able to predict whether this patient is having a breast cancer or not. We don't need the doctor. That is the use case, right? So coming back to here, understood, these are all your features. So all of these are features: radius mean, texture mean, perimeter mean, blah blah blah. Diagnosis is your y variable that you are going to predict. Understood? So what happens is how the architecture flows work. You take the data, and the very first thing that you do is you divide the data into training and test. This is your training data, this is your testing data. Again, here you have your y variable dot dot dot, and you here have your y variable dot dot dot. Okay, and you have your x variables, you have your x variables. Okay, as I told you, all of these are x variables, and this is your y variable. Okay, so I can write it down as x train and y train, and all of them as x test and y test. Everybody's clear so far? I have just divided the data into training and test, and then I have given them labels. Training data ka x variables is called as x train, y variable called as y train. Testing data x variable is called as x test, y variable is called as y test. Simple. Can we have yes or no in the chat box? Yes. That's there is a delay of two. Understood? Give me 5 yeses. Yes. Understood so far? Okay, cool. Now what I will do is there is a step called as feature scaling. See, I will teach you feature scaling, don't worry. Feature scaling, after feature scaling is done, you still have the same data, but these are all these are all converted data. Okay, I will, as I told you, I will teach you feature scaling, do not worry about it. So you have scaled down the data. Now you still have, you have a new x train. So I will write it down as x dash train. Is my voice not loud? And then this is called as y train, y dash train. Similarly, I will write it down as x test dash and y test dash. Got it? Then what I will do is there are some feature engineering steps. I'm not getting into that right now. We will be covering feature engineering at the end because this is the most important and critical step. Imagine एक है step है feature engineering करके एक step है. Okay, imagine that. And then what will happen is then you are creating a model. So let's say I will create a machine learning model. I will name it as ML1. And let's say the algorithm behind this model is decision tree. Decision tree is a algorithm. We will be studying that also. Do not worry. Now, what goes into this model is your x dash train and y dash train. Okay, so the model learns. Okay, imagine you have 700 records and 300 records here. So the model understands the 700 records. Okay, now what you do is you only pass the X test data for predictions, because you don't want to pass this. You don't want to pass this. Why? Because if you pass this, the model will know, right? This person is breast cancerous person and this is not. So model should not know about this, right? That is where the model will predict, right? So the model will now predict. How many predictions the model will do? The model will do 300 predictions, because there are 300 people. So for the testing data, model only receives these information, not the y variable. Okay, now model predicts. Okay, first customer, I think it is cancerous, non-cancerous, cancerous, non-cancerous, and so on. Now then you take the original data, y test dash. So first customer is actually cancerous, second is not, third is actually cancerous, fourth is not. Let's say I will make it as y. So fourth person is actually cancerous, but your model has predicted it wrongly. So out of these 300 predictions, imagine the model predicts 245 correctly. So what will be the accuracy? The accuracy will be 245 divided by 300 into 100. Now if I calculate it, somewhere around 80%, divided by 300 into 100 is 81.6%. So this model is basically giving you a 81.66% of accuracy. Similarly, you create multiple other models, ML1 till MLN. Let's say this is a k nearest neighbors algorithm, this is a random forest algorithm, another one is a XGBoost algorithm, and so on. Let's say this gives you 80% accuracy, this gives you 78% accuracy, and so on. Now, what happens is, out of these models, you finally take two or three models which is performing the best. Let's say decision tree gives you 81.7%, XGBoost gives you 82%. So you take these two models, and then comes the final process, which is hyper parameter optimization. Okay, whatever I'm teaching, it's always a good practice to make a note of it. If you are just watching YouTube videos, do not do that. It's a recommendation. पढ़ना है इज्जत से पढ़ो, नहीं पढ़ना मत पढ़ो. Simple as that. If you are not in front of your laptop, in front of your notebooks, please drop, watch this video later, and then come back later. So only by watching the video you will not learn. So hyperparameter optimization is that process where it's like a rigorous training and optimization process where you help the models to increase the performance. See, as an example here, I'm taking accuracy, but accuracy is not the right metrics. We will talk about it in the future. Do not worry. Right now, with our limited knowledge, I'm just taking accuracy as an example. But accuracy is not the right metrics to tell whether a machine learning model is good or not. Okay, we'll talk about it later. This is a very important interview question also. Interviewers ask you, which metrics do you use to evaluate a classification algorithm? If you say accuracy, then you are gone. The interview will be done and dusted there itself, because accuracy is the worst metrics. There are other metrics we will study. So hyperparameter optimization, after using it, let's say this model's accuracy gets boosted to 86%, and this model's accuracy gets boosted to 89%. So this becomes your model, best model. Now here, what you do is you go to your data engineering team, Boss, we have a model ready. What are our next steps? Our next steps are to productionize it. So, productionizing it. And that is where your engineers will come into picture, and then they will set up pipelines and set up automation scripts and all those things. Okay. Any doubts in the architecture so far? Of course, there are some gray areas where I have not explained feature scaling, feature engineering, but we will cover that. So, as we have completed 1 hour, the next 1 hour we'll be talking about some classification algorithms. We will get started with knn decision trees. Mathematics will be there. Just wanted to let you know that there will be mathematics. So do not think this as ki I'll just cover these algorithms upar se and then I will wind it up. No, I will be covering the mathematics behind the algorithms. So stay tuned. uh, Now, as we have completed 1 hour, let me take a 1 minute break so that I can check out the comment section. Okay. So I'm going back to the first comment section. Will we deal with a project, sir? Of course, we will be covering a project. In fact, um, we will be covering two projects. Okay. But end to end with deployment, we will do one, because you do one or five, it's same. Right. Joined from Kennedy Town. Wow. Great to see somebody from Hong Kong joining in. And then um, everybody has given. I have difficulty solving questions about the Z test, T test, chi square test, and ANOVA test. I mean, I can solve some questions, but some of them are very tricky. Can you give me advice? Um, I have some videos on all of these tests on my channel. However, for the chi square test, I have done a minor mistake in that video. Um, but other than that, I have all these videos. And I will also recommend you to go back to my statistics playlist. Go back to the part 3. I have covered all these tests in depth. Sir, what is the average salary of Gen AI or machine learning for freshers? Um, it's very dicey to say. Companies like TCS, Infosys, they usually pay you around 4 to 5 lakhs, 6 lakhs. Other companies like simple maths company, or maths company as in the math company, or any other Bloomberg, these kind of companies, they will give you around 8 to 10 lakhs. Some companies gives you around 12 to 16 lakhs also. But the thing is, do not do not worry about your first salary. Trust me, if you jump into this domain, if you get a job, 3 lakh ka ho ya 30 lakh ka, you will be able to reach exponentially to someone who has started as 15. Let's say you start as 3, somebody starts with 15. You both can be in the same salary range 5 years later. So do not worry about that part. I usually tell them, I tell all my students, please share some of your experience. I'll talk about that at the end of this video. Thank you, Neil. You have shared to these groups. Uh, we will take a 2 minutes break, guys. I hope the time in India is 9 o'clock right now. Be back by 9:05. Okay. In the meanwhile, I'm going through the comment section. So 5 minutes of water break for you all, not for me. Be back by 9:05. Okay. In the meanwhile, I'm studying. I'm going through the comment section. How many hours of class this will be? Machine learning is 12 hours, is what I'm planning for. Okay. Not everyone is curious about this field. Everyone is going for MERN, but those who are sticking here are the dedicated ones. Yes, that's correct. That's correct. Instead of going out with your family and chilling, thank you, thank you. See, my main goal is, see, Ultimately, I want my channel to grow. As simple as that. I mean, that is why I'm doing live classes. But channel will grow only when people will watch my videos, right? And people will only watch my videos only when they are motivated. So I'm trying to motivate people. It's a win-win for everybody. You join my classes for free, I get views, as simple as that. And if you wish to join my online programs by paying something, you're welcome. WhatsApp phone number to join the chat, I have given the link in the description. Okay. Please share some knowledge about jobs in ML AI, how to crack into field as fresher. Um, I'll pick this question at the end. Okay. And then any other questions, sir? Will you upload this video for? No, this is live video. No, it will be on my channel forever. So it's not like, yeah, it will be on my channel. Don't worry. Who does the hyperparameter optimization? That's a very good question. We, data scientists and machine learning engineers, we do hyperparameter optimization, and I will be covering that in depth. Do not worry. There are some techniques like manual search, Bayesian optimization, Bayesian optimization, grid search, random search, randomized search, basically. So we will be covering all of them. So we do that. Okay. Bias variance trade-off in machine learning. How does it affect model performance and what strategies can be used to balance it? Yeah, we'll talk about that. It's a very good topic. This is a very, very important topic when it comes to interviews. Bias variance trade-off. In fact, not interviews, your personal experience also. There are a lot of issues that we get in machine learning. Bias variance trade-off issues, we get issues like overfitting, underfitting, class imbalancing. Multiple issues are there. We will be talking about these issues in this program, so don't worry about it. Can we split the data after feature engineering? Usually we don't, because splitting has to be done before feature scaling itself. So splitting is your first technique. The reason behind that, again, I will explain. In feature scaling, when we talk about feature scaling, I will explain you why splitting is prior to these steps. Okay. Joined from South Africa, thanks a lot. Sir, please share interview questions along while teaching. Of course, I will. I'll tell you which are the important ones. I have a deck of interview questions also. I can send. I can send them to you. Machine learning interview questions are already there. And in parallel, I'm also creating some scenario based questions. So those questions will also be shared to you. Okay, so I have a bunch of things to share. Okay, some very specific questions about individual profiles. I'm not picking them right now. I'll try to answer at the end of the program, as in the end of the class. In case I skip out, you have my WhatsApp link, WhatsApp number. Please reach out and we'll talk. Please share interview question of data analyst topics. Yeah, I'll share some interview questions. Currently, I'm working as HR analyst. I learned both Python, SQL, and Power BI, but in day to day, I'm not at all using. I feel like I might. No, no, no. Why you see? Do not wait for your company to do. You do your own work. As simple as that. Like my company is not doing anything into deep learning right now or machine learning, but I keep on doing few things. So it's going to be your call. You install your MySQL workbench in local, get into a use case, get the data, push it into SQL databases. From SQL, create a connection, read your Python notebook or Power BI, start creating a dashboard, as simple as that. So you do not have to wait for your companies. Okay, so we are done. Moving on, it's almost 9:05. Moving on to the next topic. So this is a very high level learning path. Give me 1 second. I would also need 1 minute for water. Just 1 minute. Okay, chalo. Moving on to the next topic. I've already covered this. Okay, so I'm not covering this quickly. It's like a business understanding. You understand the problem. You understand what to solve. What is your successful measures? Then you start collecting the data. Then you prepare the data. Then you understand the data. This is nothing but EDA. Okay, then you do your engineering and then model building, explore models. Exploring models is nothing but this part, right? Where you are exploring models, then finding insights, evaluation, model iteration and deployment. Okay, so almost motamoti same thing. um Getting your dream job, oh, we'll cover that later. So some of the essential libraries that we need is numpy. Some assuming everybody has a sound knowledge on numpy. SciPy is not needed, but when it comes to NLP, yes, we will be needing SciPy. sklearn is a library that we will be using for machine learning. Matplotlib is a visualization library. OpenCV is not needed, at least for machine learning. Pandas is needed, again, these are not needed for machine learning. And Spider basically is the ID. So, yeah. Okay, let's proceed. So, training and test split. There is a method inside. So technically speaking, how do we perform this? There is a method called as train, test, split. Okay. If you Google it out, sklearn, train, test, split, you will be able to find the exact path of that particular thing. So inside sklearn model selection, we usually have this train, test, split. Okay. Using that, you can split your data into training and test. I have already explained that. The next important topic is feature scaling. Those who have already attended my statistics lectures, they might know this, but if you don't know, you know or don't know, anyways, I will cover. So let's talk about feature scaling. Feature scaling is the most important topic, because eventually you are passing your data. So you have your data. Eventually, you are passing your data into computers, right? What do computers understand? Computers understand numbers, and the best possible format for computers is binary, zeros and ones, right? So if you pass information like geography, this customer is staying in Mumbai, this customer is staying in Delhi, this customer is staying in Hyderabad, model will not be able to understand. Model sits on computers, and computers understand numerical data. Okay, for that reason, you should always convert your categorical data into numerical data. So that part is called as encoding. We will be covering encoding after this. But try to understand what is feature scaling. I'll give you a simple example that I usually give in all of my classes. Height and weight. Let's say I'm considering five people's height and weight. Five people's height and weight. Let's say 172, 170, 180, 160, 165. And weight is, let's say, 80, 80, 85, 70, 72. Now I will pause the video. I mean, I'm teaching live. Sorry. I thought I'm recording for my YouTube channel. So I'll ask you one thing. Can somebody tell me what is the units of height and weight? I mean, is this in centimeters, meters, feet, inches? What what is the unit of this? I'm asking you a simple question. Height and weight. What are the units? So I'm keeping an eye on the comment section, the live chat. Height is in centimeters. Aman Gupta says centimeters. What about others? Centimeters and kgs, right? Now, we human beings, we know that this is centimeters, this is kgs. Why? Because we have been trained with this kind of data since birth. But if you pass this data to a machine learning model, so for a machine learning model, what is this data? This data is like this. Model does not know whether this is height or weight, or is this for person or is this for dinosaurs. They don't know. For them, these are just numbers, right? So when models take these numbers, they are biased. See, if I give you two numbers, 10,000 and zero point 0.5, normal human tendency is we will think this is important, this is not important. Similarly, think from a machine point of view where they don't have a prior knowledge. 100% they will prioritize this number and deprioritize this number, which creates biasness. The models are not biased, right? The models will be biased. Now, in order to make the models not biased, we need to convert both of them into a single format. Now, let's say I want to convert this into a scale of 0 to 1. What should I do? Give me some mathematical techniques based on which I will be able to convert my height into a scale of 0 to 1. What should I do? Give me some ideas. Think it as an aptitude question, as simple as that, right? There are five numbers. You need to convert these numbers into a scale of 0 to 1. What do we do? Well, you have talked about a technical term called normalize. Well, that is true. I'm asking you a simpler explanation of that. Uh, if I divide everything by 1000, it becomes divide by 10 for weight and 100 for height. So if you divide 100 for height, it becomes 1.72. It's not in the scale of 0 to 1. But if you divide it by 0, divide it by 1000, it becomes 0.172, 0.17, 0.18, and so on, right? So this is a technique. Yeah, agreed. This is a technique. Another technique could be dividing it by the maximum number. So 172 divided by 180. So how much is this? 172 divided by 180 is 0.95. Then again 170 divided by 180 is 0.94. Right? This is another technique. Perfect. So there are different techniques based on which you can normalize the data or you can scale it down. But statistically, there are two topics, there are two concepts that is usually used for feature scaling. So I will write it down as feature scaling. Statistically, there are two techniques. One of them is called as standardization, and one of them is called as normalization. If you know the formula of them, write it down yourself in your notebook. Sorry, because you cannot write it down in the chat box. The formula of standardization is very simple. X minus x dash is nothing but x minus mu divided by sigma. Your mu is nothing but your mean. Sigma is nothing but your standard deviation. Normalization is x dash is x, sorry, x minus x minimum divided by x maximum minus x minimum. Okay. Now let's use the simplest technique, which is normalization, and try to create our new column. Let's say I will write it down as ht dash. Okay. So first of all, what is my, I'm just considering height. Okay. What is my minimum height? So the x minimum is 160. What is my x maximum? It is 180. So what will be my first value? It will be 172 minus 160 divided by 180 minus 160. What is the number? It is 8 divided by 20. So 8 divided by 20 is 0.4. For the second value, it will be 170 minus 160 by 20. So 10 by 20 will be 0.5. For the third value, it will be 0. For the fourth value, it will be third value, it will be 1. Third value, it will be 1. For fourth value, it will be 0. And for fifth value, it will be 165. 5 by 20, 0.25. So these are my new scaled values. You can see feature importance wise, nothing is changing. Person C was still the tallest. Here also, person C is still the tallest guy, having the highest number. Person D was the shortest. Person D is also having the lowest value. Using the same technique, I will also calculate my weight dash. So what is my minimum weight? My minimum weight is 70. And what is my maximum weight? My maximum weight is 80. So the first record, it will be 80 minus 70, 10 by 10, it will be 1. Maximum is 85. My bad. For the first record, it will be 80 minus 70 divided by 85 minus 70, which is 10 by 15, which is 0.67. For second record also, it is 0.67. For third record, it will be 1. Fourth record 0. Fifth record, it will be 72 minus 70 by 15. 2 by 15, how much is 2 by 15? 2 by 15 is going to be 0.13. And these are my scaled values of height and weight. Now, if you pass this to a machine learning model, what does the model see? First record is 0.4 comma 0.67, right? First one is 0.6. It is 172 minus 160, 12 by 20. 12 by 20. Oh, sorry. Point 6, point 6. My bad. Huh. Okay, good. Point 0.6, point 0.6 and 0.67. Now, instead of the original number, which was 180 comma how much 172 comma 80, now it is having a better number. So the model treats both these features equally, where because they are in the same range. So this is a classic technique of feature scaling. If you take the same example, let's say I will only take the height as an example and use standardization to solve it. Okay, let's solve it for both. Okay, so my height is 172, 180. Okay, I'm taking new examples. Okay, 172, 180, 160, 165. Height, weight is, let's say, 80, 85, 70, 75. Okay, now you want to use standardization. Standardization formula is x equals to x minus mu by sigma. First of all, what is mu here? Mu is mean. So what is the mean of height? The mean of height is very simple: 172 plus 180 plus 160 plus 165 divided by 4. It is 169.25. What is the um, mu of weight? The mu of weight will be 80 plus 85 plus 70 plus 75 divided by 4. It is 77.5. Mathematically, if my calculations are wrong, just notify me, okay? So my mean is clear. What about standard deviation? Standard deviation, formula wise, I remember the formula, but I will not use the formula. Rather, I will use Excel to solve this problem. Let's say my numbers are 172, 160, 180, and 165. And for weight, it is 80, 85. This is 180. This is 160. 85, 70, and 75. So what will be the standard deviation here? So I will use standard deviation of sample is 8.69. Standard deviation of sample. Why are we using sample here? And what is the difference between the formula of sample and population? If you know, well and good. If you don't know, go back to my statistics class and study. For samples, the denominator has n minus 1. For population, the denominator has n, right? The reason is already explained in my statistics video. So I'm going to use 8.69, and for B is 6.45. Now I will do the calculation ht dash and wt dash. So the first record, I'm doing some calculations here, okay? For the first record, what is my x dash? It is 172 minus mu, which is 169.25, divided by um, sigma, which is 8.69. So what is this value? 172 minus 169.25 divided by 8.69. It is 0.3. Cool. For the second record, 180 minus 169.25 divided by 8.69. How much is this? 180 minus 169.25 divided by 8.69 is 1.23, and so on, right? Similarly, for weight, let's say for the first weight, I will calculate it as 80 minus 77.5 divided by 6.45, which is 2.5 divided by 6.45, it is 0.38. So these are your scaled numbers. So feature scaling is important because if you don't do feature scaling, the model will be biased towards certain columns. The next topic is, remember there was a question. If I go back to my chat box, there was a very, very important interview question, which is, why do we do, okay, this one. The question was, can we perform training and test split after FE? Now, we don't perform training and test after FE. In fact, training and test split has to be done immediately. The reason will be explained. So, imagine you have your data. Okay. So, you divide the data into training and test. This is training, this is test. Now, training data basically goes into the machine learning model, right? Both the X train data and the Y train data. But while predicting, you are only passing the X test data, not the Y test data, right? And the machine learning model knows about this data. I'll explain that one. Which one is better, normalization or standardization? Again, it's a very good question. I'll tell you after this. Now, try to understand this thing. X train and Y train both goes into machine learning model. But when you are predicting, you are only passing X test data, right? Now, directly you don't pass it to the machine learning model, right? What you do is you perform feature scaling. So you perform feature scaling here. So all these are scaled values, right? Then you pass it to the model. Imagine a new customer comes in who has all this information, like the X information. Now, can you directly call the machine learning model and do the prediction? No, right? Because this data is raw data. Try to take an example. Let's say this is my, let me directly download this and show it in Excel. Okay. Imagine, see, I'm just deleting multiple columns just for ease of understanding. Okay. Imagine you have these many features. Okay. Again, I'm deleting records beyond this. We'll keep it simple. We have these many records. So this is, let's say I will write it down as cancerous, non-cancerous, cancerous, non-cancerous, cancerous, non-cancerous, and so on. So this 6 records is your training data. Okay. These 6 records are your training data. Or maybe one more record. Let's make it this. These all are your training data. Now, are you passing this exact information to machine learning model? No, right? You are converting them into some other numbers. Let's say the standardized number is 0.4. This standardized number is 0.5. This standardized number is, let's say, 1.2. This is, let's say, 0.5. Let's say this is 0.5 and this is 0.4 or 0.4. These are your scaled values, right? So you are not passing all this information. Instead, you are passing the scaled numbers here. So when a new customer comes in, will you directly pass these numbers to the machine learning model for prediction? No. Rather, what you will do is you will do the feature scaling here and then pass it. Sorry. You will do the feature scaling here and then pass it, right? Because your machine learning model is trained on scaled numbers. So if you directly pass these numbers, model will be not be able to understand what the hell is these numbers, right? So you eventually have to convert them into normalization or standardization and then pass it to the model, and then the model will predict. Now, with just one record, let's say you are doing a prediction on one customer. With just one record, how will you be able to do the normalization or standardization? Because for one record the mean is also the same, right? Let's say 13.71. What will be the mean? Same, 13.71. What will be the standard deviation? Same, just for one record, right? So here, in order to do feature scaling, you basically use the mu and sigma of your training data. Try to understand this thing. It's a very important topic. Many YouTube videos, they have not explained this thing. You will be using the mu and sigma from your training data. Okay. And that is one of the reasons why, when it comes to practicals, you will understand. Because when we are doing the feature scaling, we usually do fit and transform. We do fit and transform for training data when we are doing feature scaling. I'm talking from the code point of view. Okay. In coding, we have fit transform for training data. But for testing data, we only do transform. The reason behind that is training data goes into the model, we fit and transform. For testing data, we use the configurations, and based on that, we convert the testing data. We do the feature scaling of testing data. So that is why we use fit transform for training data and transform for testing data. Now, this is a classic question that is asked in interviews. If you Google, you will also find why fit transform for training data and transform for test data. You will definitely search lot of blogs, lot of Stack Overflow posts on this same question. Why we use fit transform on training data, but only transform for testing data? The reason is very simple. I just explained you. Okay, because of the same thing. Okay, now coming back to the question asked by, if I'm reading your name correctly, Narotham, right? Narotham Gidipali. The question is, which is a recommended topic, whether we use normalization or standardization. Now, I will try to ask others who are on the call, any idea when to use normalization or when to use standardization? See, I will give you the answer, the solution for that. I will also tell you which one is best, but I want to hear from you. What do you think? What the viewers think? Which one to be used in which scenario? See, the simple explanation is, if your data is following a normal distribution. Now, you have your data, right? Let's say let's say you analyze your different columns. Let's say you have multiple columns like tenure, age. You go and check whether they are following a normal distribution or the data is skewed. So the general answer to this question is, if your data is normally distributed or near to normal distribution, then usually go for standardization technique. If not, then go for normalization technique. This is the usual answer that you can give to the interviewers. On top of that, you can also tell them some extra gyan, that choosing between normalization and standardization should not be done. You can arbitrarily choose one of them, because choice of normalization and standardization has a very less impact on the final models. Why? I'll explain you. Because if I go back to the architecture, usually what we can do is, again, this is an interview question answer, okay? But usually we don't do this. Answer, the way you can answer this is, while going ahead, what we can do is, first we can select standardization arbitrarily, because checking the standardization, the normal distribution for each and every column is not wise. Some columns might be following Bayesian distribution, sorry, Gaussian distribution, some not. So taking a call between standardization and normalization is difficult. So we can arbitrarily go for one of them, build a model, and then again come back to this step, again do normalization, again go ahead and again build the model. And then we can compare this model with this model, which of them is giving you best results. We can choose that technique. But this is a tedious process. Going back and forth just for the sake of identifying standardization is better or normalization is better is not recommended, because machine learning processes are time consuming. We should focus more on hyperparameter optimization or feature engineering, because the choice of standardization and normalization is almost very both techniques are feature scaling techniques, both are very close to each other. So choosing one over the other will not have a huge impact on the models. Okay, I think that's a good answer that you can give in the interviews, and I'm pretty much sure the interviewer will be happy to hear that. Okay, so because more focus should be put here, this is the most important step, because this is where the game change happens. You're boosting your algorithm here rather than going back and forth for identifying standardization or normalization. No, right? So that is my answer. If I get this question, I answer this way. Got it? Moving back to the slides. Feature scaling is understood. Somehow I have regression algorithms here, but I'll not cover regression right now. We will have regression tomorrow. We will get started with the classification algorithm. Okay. Um, as I told you, I'm aiming for a 12 hours lecture on machine learning, but in case we are not able to cover that in 12 hours, we will try to have extensions. Okay. So maybe next weekend's classes could be like 2.5 hours, but this weekend we will stick to 2 hours. Okay. Okay. Classification algorithms. Now, there are different classification algorithms. Classification problem is understood. Everybody understands the problem statement. Now we will be getting into classification algorithms. I was talking about this, right? In the Miro board. I will be sharing this board with you. Anyone with this link can view, copy the board. I will share this link with you in the description so that you can go through the class lectures in the future. Okay, so everything is here. Now, coming back to this architecture diagram, I was giving you an example of machine learning models, right? Um, so these are the models that are majorly inside classification. We have KNN, we have decision tree, random forest, naive bayes, support vector machines, logistic, and of course there are some advanced algorithms which we will be covering in ensemble learning. Okay, ensemble learning, which is boosting and bagging algorithms. Right now we'll focus only on the basic algorithms. So the very first algorithm is k nearest neighbors. Okay, very um, one second. Um, there is a glitch. I'm not able to see. Yeah, I'm back. Okay. So the very first topic is k nearest neighbors. I'll try to explain using an example. Okay. Now, before getting into the algorithm, I have few mathematical topics to cover. Okay, because KNN is based on the principles of some mathematical concepts. So before that, let's try to talk about it. Let's say I have, this is a two-dimensional graph, x and y axis. I have point A, which is, let's say, 2 3. I have point B, which is, let's say, 8 6. Now, anybody knows what is the distance between A and B? What is the formula? It's a simple mathematics question. Many of you might not remember, which is completely fine. I'll just wait for 1 minute and see whether you are able to answer. If not, I will answer anyways. What is the distance between these 2 points? Mathematically, if you are able to get me the answer, I'll wait for 2 minutes. If not, I will answer. So the formula of a line is very simple. Imagine the coordinates are x1 and y1, and here the coordinates are x2 and y2. So the distance between 2 points is usually x1 minus x2 square plus y1 minus y2 square root over. Can you use this formula and tell me what is the exact value of AB? What is AB? Perfect. We have answers in the chat box. Great. What is the what is the final value of AB? If I take x1 is 2 minus 8 square plus 3 minus 6 square root over, which is 6 square, which is 36, plus 9 root over, which is 45 root over, which is 6 point something. I'm not sure exactly, but somewhere around 6 point. Yeah, I'm 6.7. I'm correct. Okay, 6.7. Now, jargon alert. Here we call this as Euclidean distance. Euclidean distance. Okay, the message is held for review. Service, your comment has gone for a review. Anyways, okay, moving on. Why am I talking about Euclidean distance? Because KNN algorithm is based on the principles of Euclidean distance. So I'll take an example. Now let's say, can I change the color of my pen? Well, I am not used to this tool quite a lot. No, I cannot change the color. That's weird. No. Okay, anyways. So let's say I'm drawing two classes. Okay. I will write it down as breast cancerous and non-cancerous. I'm taking the same example of breast cancer. Now imagine you have a data set like this. If tomorrow a new patient comes in with all this information, we should be able to predict whether the patient is cancerous or not. That is our end goal, right? So here I'm just taking two features, okay, x1 and x2. Let's say my x1 is radius mean and my x2 is texture mean. So this is the first customer. So let's say the first customer is here. Not customer, patient. It's patient, not customer. Class 1, class 1, class 1, class 1, class 1. And this is cancerous, 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 cancerous. Let's say these are my two classes. Let's say this is non-cancerous and let's say this is cancerous. Okay. And this is my distribution of the data. See, I'm taking an easy example for understanding purpose. In reality, you cannot visualize your data like this. Why? Because here I'm only taking two features. In reality, you don't have two features, you have multiple features, and multiple features cannot be drawn. Human eyes are only restrictive to three-dimensional space, and on paper, on screen, I can only draw two-dimensional data. So just think your imagination to understand this problem. Now if there is a new data point, let's say there is a new data point, And let's say the data point lies here. I'm drawing it as a circle. This is the new data point. Now the question here is whether this person is cancerous or non-cancerous. We need to please also provide, okay, I'll provide the link, no problem. My problem is to identify whether the customer why am I telling customer, patient, whether the patient is cancerous or non-cancerous, and using KNN algorithm, right? First of all, try to understand what is KNN. KNN means K nearest neighbors. Okay, and here K value can be anything. Usually when you are solving a binary classification problem, now this is a binary classification problem. Why? Because there are two classes. The number of classes are two. So your K value can be 3, can be 5, can be 7, something like that. Let's say my K value is 3. That means I need to find the 3 nearest neighbors. Now what I will do? I will try to take the distance between this data point to all the existing data points. Right? Now I will use the same algorithm x1 minus x2 square plus y1 minus y2 square root over, and I will calculate everybody's distances, right? So I'm doing control Z to undo this. Now imagine the three nearest neighbors are this, and this. Now, as per the voting, two are falling for non cancerous. So, your final prediction will be non cancerous as per Kanan algorithm. Now, if you choose K value as 5, let's say as per K value 5, it seems that the patient is cancerous. Okay, so this is how you predict based on KNN algorithm. The choice of K is a hyperparameter, but mathematically you understood, right, how it happens. Now I will explain using another example. Okay, I have an Excel sheet, sheets.google.com, because I usually give this example in all of my classes. So I'll try to explain using this example. Okay, I'm deleting this, deleting this. Okay, so this is a sample data set. Okay, uh, this is a sample data set. You have name, you have age, you have gender, you have game. So given these inputs, we have whether the person likes cricket or football. The question that we are solving is, for a given player, which type of game he or she will prefer. We need to predict the game. Imagine the new customer is Satyajit. His age is 34. He is male. How to find K value? When we jump into practicals, I will explain you. Okay. K value is a hyperparameter. Okay, I will explain that. Don't worry. If you go to the sklearn KNN algorithm, here, this is your K value. This is a hyperparameter. By default, the value is 5, but you can tweak it. Okay. When we jump into practicals, everything will be clarified. Do not worry. Problem statement is understood right now. There is a new customer, Satyajit. Age is 34. He is male. Whether he will like cricket or football, that is the question. Now, using KNN, how do we solve this? First of all, how many features do we have here? There are three features, right? I will denote using orange color. Okay. Now, is name important? Is name a feature? No, name is not important. So I will just ignore this name column. So, because if there is a candidate called as Aman who loves football, tomorrow if another Aman comes, will he also like football? No, right? Name is just a random feature, not important feature. So I'm deleting. So the only important feature is age and gender, right? Age and gender. Game. What is game? Game is going to be my y variable. So I will probably take it to I'll take it to Miro and explain you, because okay, this is my data. Okay, now what I need to do here is, can I directly pass gender into our machine learning model? No. Why? Because this is a categorical data. Okay, so we need to first convert it into numericals and then pass it to our model, right? So let's say I will be creating a new column. So I'll go back to Excel. I will create a new column, insert one column to the right. So my new column is, let's say, gender new. So all the males I'm giving as 1 and female as 0. See, again, I'm arbitrarily using numbers. Okay, I'm not prioritizing male as 1 and female as 0. I'm just arbitrarily giving them 1 and 0. Okay, now gender new becomes your new column. So just ignore the gender column. Okay, so you can ignore this particular column. Now you have two features, age and gender new. Now you need to find the, yeah, it's a dummy variable. We'll cover feature encoding is a part of the program. We'll cover that. For now, forget about encoding. Okay. Now we need to calculate the Euclidean distance. Okay. Let's say based on these, if you draw a diagram, just imagine these are the coordinates. Okay. And this is your the record that you need to identify. So for this candidate, it's going to be 1. So what is the Euclidean distance here? Paste as table. No, paste as a sticky note. Ah, why it's not working? Ah, I will use this. Okay, so let's say I'm going to use this as my base. I'll bring it little bit down, make it little bit short. Okay, now what you need to do is you need to find the Euclidean distance. Now this is your the coordinates of your column that you are going to predict is 34 1, right? What will be the coordinate for the first record? It is 25 comma 1, right? Now imagine this is your x1 and y1, this is your x2 and y2. What will be the Euclidean distance here? So it will be x1 minus x2 square plus y1 minus y2 square root over. So if you calculate, this will be 9, right? Similarly for this one, if you calculate, it will be 5. For this one it will be um, 23. For this one it will be 16. For this one it will be 5. For this one it will be 1. For this one it will be 34 minus 18 square plus 1 root over, which is, this is going to be 16 square. 16 square is how much? 16 into 16 plus 1, then root over is 16.03. This is going to be 16.03. This is going to be 13 point something, let's say 0.5. This is going to be 12 point something, and this is going to be 3. Okay, these are going to be your Euclidean distances. If you have any doubts how these numbers are calculated, ask me. Okay, we are just using the formula, this formula, x1 minus x2 square plus y1 minus y2 square root over. Okay, now after this is done, let's say my k value is 5, because in my algorithm, where is my algorithm? Oh, did we close this? We closed it. So let's say my k value is 5. What are the 5 nearest neighbors to this candidate? Who has the lowest Euclidean distance? This has the lowest, second lowest. Then we have 5. Then we have this, and then the fifth lowest is, let's say, this one. So this is cricket, this is cricket, this is cricket, this is football, this is football. Now majority is playing cricket, so the prediction for this customer who is 34 years of age and a male person is going to play cricket, and this is as per KNN algorithm. So mathematically this is how KNN algorithm works. Okay, practically if we jump into practicals, it will be even more easy and simpler. So practicals are very very simple. Building the first machine learning model is going to take you like 5 minutes literally, but building the best machine learning model could take you ages. Okay, so that's all about today's class. I think we'll wind up here itself. Almost it's 12:30 for me. I wanted to finish decision tree today, but we were little bit slow, which is fine, no problem. There is no rush. We will be covering rest of the classes, rest of the topics in the upcoming videos. So tomorrow's agenda is very simple. We are going to cover decision tree, the mathematics of it. We will be covering random forest, the mathematics of it, XGBoost and various. No, XGBoost is not covered today. XGBoost is going to be covered later in ensemble learning. Then we will jump into regression. Of course, mathematics. Regression has a bunch of mathematics. Okay, we will be covering that, and finally we will have a small practicals around classification and regression. This is not an end-to-end project, but just a little bit practical grinding. Okay, that's it. That brings to an end of today's session. But I will not close the call right now. I will keep the call open for the next 5 to 10 minutes. In case you have any questions, you can ask me. That's end of our part 1 today's class. Just repeating once again that in case you do not want to wait for YouTube live classes, feel free to go through my curriculum. My curriculum has more than 140 hours of lectures. It's a very in-depth, detailed curriculum where I'm also providing chat support. So when you join this program, basically you will be a part of a WhatsApp group, not like other WhatsApp groups. My student WhatsApp group is a very limited WhatsApp group, which is very active. So you will be a part of the WhatsApp group, and whatever questions you will be asking, I will be answering them. And this is a very in-depth program. In case you want to get started, see, machine learning has 85 lectures, then NLP has bunch of lectures, time series has bunch of lectures, generative AI has a bunch of lectures. So a lot of things are there, and all of these things I'll not be able to teach everything on YouTube. I will try to teach 60-70% on YouTube. But yeah, in case you need a detailed program, check this out. Okay, in case you have any questions around whether you are applicable to learn AI or data analytics, that also I can do for free. Send me your resumes, tell me what you are aspiring to become. Do you wish to jump into AI? Do you wish to jump into data analytics? I can go through your resumes and give you some feedbacks. Okay. Um, Repeating once again that you usually do not pay for the courses, you pay for guidance. Materials are already available on YouTube. Even there are many channels where machine learning, deep learning videos are also free of cost available. But while you jump into this journey, right, you will get thousands and thousands of questions and doubts. So think from that point of view that you are paying for that, not for the videos. I will be guiding you in the program. But yeah, anyways, if you don't take the program, also still you are part of my other communities where I also help and give some feedbacks. Okay, okay. Um, Now I'll look at the comment section in case you have any question. Fast press from next. Yeah, next classes we don't do bullshit. Directly we'll start with our lectures. 5 minutes of recap, and then we will jump into the real topics. Okay, questions. Anybody? 26 people are still watching. Any questions do you have? You can ask me. So I'll go back to my StreamYard so that I can stop sharing. Um, yeah, questions, guys. Okay, assuming there are no questions, thank you all for joining in. It was a pleasant experience for me to start my YouTube sessions once again. I was very active on YouTube two years back. I did live classes on Power BI, SQL, many topics. Now we are back with machine learning, and going forward, we will try to have more and more topics coming in. I don't see any description or links. You can. Maybe give some time. This is a live class. Maybe the links are not visible, but I'm pretty much sure, yeah, links will be there. Go to the description, you will find all the links. My program link is there. My WhatsApp group is there. Below the agenda, go below the agenda. There is a join the WhatsApp group that you can join. um, and then syllabus is also there. The reason why I cannot start a bit early is 8 p.m. IST is 10:30 for me. So if I have to go out with my family, because it's Saturdays and Sundays, so at least I can go out and I can come back by 10 o'clock, and then by 10:30 my local time I can teach. So 8 p.m. is a sweet spot. That's why I started at 8 p.m. But if you wish to join, I mean, there is no way we can prepone it. I'm really sorry for that. Last 2 minutes, I'll pick last questions if you have. Why are freshers generally not preferred? They are preferred. See, fresher issues are not only in 2024. In my college days, when I graduated in 2011, we had the same problem. सो फ्रेशर्स का सीन जो है इट्स नॉट न्यू द ओनली प्रॉब्लम इज इन द डोमेन ऑफ AI and data analytics. The number of jobs are increasing, fine, it's increasing exponentially, but the number of students entering in this domain are way more. So if you have to stand out, you have to be serious. If you don't spend, again I'm repeating, I'm not asking you to pay me. You pay me or pay any other course, I don't care. But if you are serious, do an initial investment, go for a structured program, learn, apply for your practicals, be good with your portfolio projects, apply for jobs, and you will get it. There are fresher jobs. It's just that the number of jobs with respect to the number of students, there is a huge gap there. Freshers are preferred. No, no, there is no doubt about it. I have so many fresher students who passed out from my previous batches, they got jobs. But again, the ratio is very low. I want to do data science for banking. That's a really good thing. Financial banking, especially this financial banking part or investment banking part, they are crazily growing in Hong Kong, especially in Hong Kong. The Hong Kong is the financial capital of Asia, right? So here we have a lot of investment banking and companies like Hang Seng, HSBC, Morgan Stanley. They are doing a lot of things into data science and generative AI. So it's a good domain. If you want to learn data science for banking, you just have to learn all these concepts and then apply for your own domain. So learn classification, try to do a research. What are the use cases into classification in banking sector? Practice it, do a end-to-end project, and write it down in your resume. Nowadays, people are expecting you to have some fancy use cases in your resumes. So basic projects, if you write down in your resumes will be immediately cancelled out, rejected. I'm a 2018 pass out and now I want to switch. Do I have any chance? 2018 pass out, but is it like a complete gap? You are not doing anything. If you are doing something, you are into different domain, it's completely fine to switch, no problem. But if you are completely jobless, it's going to be difficult, not impossible. uh, but you can show some medical proofs of your gap, maybe some family problems, or you were doing some freelancing. Many people take an excuse of freelancing or family problems, and then they have also got jobs. So see, there are chances. If one out of thousand can get a job, then I believe you can get the job that as well. That is my belief. That's it. So you have to be positive. Okay, thank you all for tuning in. It was a wonderful session, at least for me. Please do not forget to like, share, and subscribe the channel. Like this video. Go and like this video. And after this video is over, at least the live part is over, requesting you to go and comment, use the comment section and put something into the comments, because in YouTube there are three aspects based on which your video gets more and more views. It's likes and live comments, not live comments, video comments, and then shares. Okay, sir, job market in India for Gen AI. There is a job market. It's My answer remains the same. Data analytics and generative AI, these are the two areas where you can focus on. If you are focusing on core machine learning or deep learning expertise, well, it's going to be difficult in 2024 especially. If you want to become a data scientist, you should focus on a career path which is AI engineer or Gen AI engineer, where you can focus on Gen AI tech stacks in your profile. But to learn Gen AI, there is a path. Machine learning is nothing but ABCD, and then after machine learning, you learn NLP, and then deep learning, and then transformers, and then generative AI. You cannot directly jump into generative AI. That is the only problem. Okay, and trust me, generative AI in the market right now, there is no structured program, and I can bet my life on that. Krish Naik posted something on Udemy, but again, there are a lot of flaws in that course as well. On Udemy, there are some generative AI courses. There are flaws because generative AI space is new. many tech people like me, they don't even know what exactly the curriculum should be. But I already have cracked it. For generative AI, it's going to be very simple. It's going to be, you need to learn about transformers, you need to know everything about NLP, you need to know about the self attention technique, encoder decoder techniques, contextual embeddings, need to know about different types of birds, GPT architectures, LLM basics, prompt engineering, RAGs, and then start working on projects. Yeah, if you're into different domain, Aman, then not a problem. You can easily switch. If you are not working anywhere, that's where the problem will be, if there is a gap. But if you're working in a different domain, that's completely fine. 100% of my students are into that space only. Somebody is a HR, somebody is something else, and they get into this domain, so it's possible, no problem. Okay, guys, thank you all for tuning in. See you tomorrow, same time, 8 o'clock. Um, that's it. See you tomorrow at 8 o'clock. Bye bye. The link is not yet live. I will be making it live and posting it on the WhatsApp groups. If you are a part of the WhatsApp groups, you will receive it. If not, directly tune into my channel at 8 p.m. tomorrow, and you will be able to watch out the videos. See you. Thanks. Bye bye.